types as provided by Unity. We will try to create a convincing, realistic lighting for our basic scene. Without any type of lights, the scene we create will be dark and dull. Lights are required for ambience and a feeling of what time and season it is in our site. In Unity, you can toggle the lighting in the scene window. Without any effect of light, you can clearly see geometry and materials, but everything is flat. However, when we activate the lights toggle, at the moment our scene is dark and very dull, as there are no light sources added. We now add a point light from the game object menu. This immediately gives a bright zone where light is emitted. Point lights are the least demanding in real-time projects. They shine equally in all directions, so you only need to concern yourself about their position. We can control range, color, and intensity. Avoid making lights too bright, as this will create pure white areas with no details. It is best to place a few different point lights and vary their color a bit, so objects get a sense of depth. Now add a spotlight to the scene and play with its direction. Here, position and rotation play an important role. The spotlight is projected in a cone shape. Adjust the spot angle either in the inspector or by dragging the yellow handles in the scene view. The third type is a directional light. Its position is not important, as this light will not attenuate over distance and all light is emitted in a single direction. However, to better see the effect of the directional light, we will disable the other light sources. There is also an area light, but it does not work in real time and requires a Pro license. It is used for light mapping, which will be discussed later on. It is best to apply the directional light as your first main light source, usually being the sun. This defines the exterior light. Also set its render mode to important so it takes priority over other light sources. You can then apply other light sources to even out lighting and brighten up interiors and all areas that are too dark and flat. Since real-time lighting takes quite a toll on performance, focus on the main light sources first. In this video lesson, we introduced lighting in Unity. They are easily placed, but it is very difficult to get a convincing and varied lighting scheme, especially in architectural interiors. Exteriors are a bit easier, so in the next video, we will focus first on creating a sun. In video 2 of section 4 on lighting, we create a daylight system, defined by a sun and some kind of environment lighting. Most architectural projects can be seen both from the outside and from the interior. The outside is the easiest to manage, as this is largely a result of the direct light of the sun. Remove all our lights and add a single directional light. Name it Sun and position it in the middle of the scene and just above the building. While its position is irrelevant, it helps us in better seeing the objects in the project. Set its color to a yellow that is almost white to give it a warm hue. Directional lights can cast shadows, and this is really required for most architectural scenes. Activate the hard shadow and slightly lessen the shadow strength to 0.8. The resolution can be used to refine the shadow edge, while the render mode indicates which lights get priority over others. This is the only light source that can cast shadows when you use Unity free, and you are restricted to only apply hard shadows. In the transform component of the directional light, you can adjust the X rotation, which is the height of the sun, and the Y rotation, which is the direction of the sunlight. To mimic the effects of the sky that gives our scene some overall bluish lights, we can add 2 additional directional lights. Adjust their rotation with the Rotate tool so they shine from opposite directions as the sun. You best do this from a top view position. Move them a bit to the side to assist the aiming. Turn off their shadow and make them less bright than the sunlight. You should also give them a bluish tint, which will colorize the shaded areas from our main sunlight. In this video lesson, we added the sun and created some shadows. At this point, our overall exterior lighting is set up. While it is not yet really convincing, we will revise the lighting scheme later on. In the next video, we will focus on interior lighting. In the third video of section 4, we continue our lighting setup for the interior parts of the building project. Since our directional light casts shadows, the majority of our interior is not being lit by the sun. We compensated this a bit using additional directional fill lights in the previous video, but we can do better than that. Let's first move our viewpoint somewhere inside the project to see how dark and dull our interior model is at the moment. Navigate to a top view in an isometric projection and switch to the wireframe display mode. Add some point lights and place them slightly underneath the ceiling of our room. Add about 6 of them. Adjust their range and intensity and give them a yellow, slightly greenish color. In addition, we can add a slightly yellow spotlight that mimics the sunlight falling through a window. To see what we are doing, we temporarily disable the sun and the additional point lights. For more complete lighting, you can also add one or more bluish lights from the window side, opposite from the sun. While Unity also has an area light, it only works in Unity Pro and not in real time, so we ignore it here. Turn on all lights to see their complementary effect. And finally, to compensate the quite dark and dull ceilings, we can create an additional subtle bluish directional light that can be used to compensate the sun. Make it a child of the sun, positioned in exactly the same place, but with local rotation of 0, 180 and 0 around the X, Y and Z axis respectively. You could call it a fill sun or an anti-sun. Beware that the interior lights could interfere with exterior lights, especially since they don't cast shadows and will shine right through all objects. With some custom scripts or using a culling mask, you could toggle them only when the player is about to enter the room. In this video lesson, we added a series of light objects into a single room to light it up properly. In the next video, we will look at the light mapping process, which could help to create more extensive lighting scheme. In video 4 of section 4 on lighting, we introduce the light mapping process. We will use this to calculate our lighting instead of relying on real-time lights. There is only a single directional light that will cast a shadow, unless you switch to a more advanced lighting system, but then you cannot use the free version of Unity anymore. Moreover, lighting is hard to calculate, especially on mobile devices. Light mapping is a technique where all lighting is calculated in advance and captured in an additional layer of textures that are mixed with the regular materials. Luckily for us, Unity includes a complete light mapping system that is fully integrated and fairly easy to use. However, before we can do this, we need to prepare a few things. All pre-calculated lights will need to cast a shadow. And while this is not possible in the viewport, the light mapping process takes them into account. Hard and soft shadows both work. Then we need to inform Unity about which objects are meant to be fixed by activating their static attribute. Do this for all models, objects, and lights. You'll get a dialog asking to do this for child objects as well, which is what we want. To be able to store the light map on objects, they need a special UV2 mapping type, where each part of the map is only used by a single triangle or face of the geometry. All default Unity primitives have the UVW coordinates already defined. But when loading models from external files, the importer settings can automatically add these coordinates for you when you activate the option Generate Light Map UVs, which is really helpful. Although most 3D visualization systems do support this process as well. Now we can open the light mapping panel from the window menu and dock it somewhere conveniently. Finally, store our scene, as the light mapping process needs to generate new textures in a subfolder using the same name as our scene. In this video lesson, we prepared our scene for light mapping using static objects, UV2 coordinates, and lights to cast shadows. In the next video, the actual light map calculation is performed. This is the fifth and last video in section 4 on light. Here we will complete the light mapping from the previous video. While we could start the light mapping directly, it is best to first go through the most important settings. We usually start with a fast and approximate first attempt to check the lighting level, and then refine the details a bit at the cost of longer rendering times. After our preparation work, static attributes, UV2 coordinates, and lights with shadows, you can now open the light mapping tab. We leave the default model to single and the quality to high. If you do have a Pro license or are in your trial period for the Pro version, you can set bounces to 2 or 3, which activates an advanced lighting system integrated into light mapping. This is highly recommended, as it takes indirect and environment light into account, which is nice for exterior scenes and essential for interior scenes. It does take longer to render, alas. Ambient occlusion is a rendering trick that accentuates corners and objects that are being obscured by nearby objects. While not completely physically accurate, it creates a convincing depth into the shading of the scene. It is available in all Unity versions and is also highly recommended. To avoid artifacts to occur, ensure your model is a clean, solid closed volume with no hidden faces. The resolution defines how fine you will sample the lighting. Start from a very rough value of about 10 to 15 pixels per world unit for your first attempt. You can increase it afterwards when you are certain about the achieved light balance, as it will only refine the shadow and details, but at the cost of a much longer rendering time. Now you may press Bake Scene. Double-check the console for possible error messages. If all goes well, you'll see a blue completion indicator in the bottom right of your screen during rendering. After a few seconds or minutes, you'll hopefully have your baked light. Unity automatically sets the correct maps on top of the geometry and adjusts the shaders properly. Use the third or first-person character in our scene and walk around the model to see how it looks. Notice that while the sun is pre-calculated, our third-person character is still casting real-time shadows from the sun. If you have a Pro license, you can also add bounced lighting using global illumination rendering techniques. And you can also use environment lighting, which will brighten up all non-lighted areas considerably. Finally, you can also use area lights to simulate diffuse lighting objects or light entering a room through the windows. It even supports light-emitting materials if you use the right shader. Without a Pro license, you will have to mimic these effects. For instance, by adding additional fill lights on places where bounced light would appear. Luckily, ambient occlusion is still available, which ensures that you get more profound lighting and accentuated object geometry. Remember that the calculation of light takes some time initially, but there is no need to calculate lights in real time anymore. This is especially valuable for mobile devices if they have enough memory to store the light map textures. In this video lesson, we calculated our lighting using the integrated light mapping from Unity. This concludes section 4 on lighting. In the next section, we will introduce animation techniques.